Okay, number 2 says there's a sequence of numbers, alpha 1 up to alpha k. They want to say distinct real numbers on the interval between 0 and 2 pi. Kind of reminds me of the first question. It says it satisfies this equation, which is sine alpha plus cosine alpha equals minus 1/3. And they want to know what the sum of the roots are. Very similar to the other problem, by the way. So let's go to the whiteboard. This is number 2. And I got to go back and read the question again. And what they have here is they have these alphas. And these alphas are in the interval between 0 and 2 pi. Right? They tell me that these alphas are a solution to an equation, by the way. And that equation is sine alpha plus cosine alpha equals minus 1/3. Now, one thing you could do to solve that, it's good, and you want to get into one function, either sine or cosine. You could actually square both sides. But the problem with squaring is I'd have to check the solutions to make sure they're not extraneous. So what I'm going to claim over here, there might be an easier way of doing it. What I'm going to do over here is recognize that this might have something to do with a pretty simple sum formula. So what I'm going to write down is a sum formula that that I'm going to say kind of easy to verify, that the sine of 45 degrees plus some number alpha. Well, it's a sum formula. It certainly, you should be familiar with this over here. It's going to be sine of 45 degrees. I'll go back to radian later, by the way. Cosine of alpha. And then plus the sine of alpha, the cosine of 45 degrees. Let me keep going through this. Sine 45 degrees plus alpha. The sine of 45 degrees is 1 over root 2, cosine of alpha. And then I get plus the sine of alpha times the cosine of 45 degrees, 1 over root 2. That's the whole reason for picking 45 degrees, by the way. They're the same number. Multiply both sides by root 2. That's root 2 sine 45 degrees plus alpha is going to be cosine of alpha plus the sine of alpha. And that's what I wanted. And what does that equal to? It's actually equal to minus 1/3. All right, let me write this down now. So the sine of 45 degrees plus alpha is equal to minus 1 over 3 root 2s. This is not a nice number, by the way. However, I do know the number is going to certainly produce angles that this is going to work for. I want to point out, when I look at the sine function, it looks like this over here. And this is the number minus 1. And minus 1 over 3 root 2, it's going to hit it twice over here and there somewhere. I'm just saying I don't know exactly where it hits it, but I can write the reference down. All right, so I'll write the reference down. So what's the reference going to be? And it's going to be the arc sine of 1 over 3 root 2. All right? So I'm going to write this 45 degrees in terms of radian measure now. You don't have to, but it did. You know what? I'm not going to do it. I'll just leave it as 45 degrees. All right? In that case, I'm going between 0 and 360 degrees. All right? So I'm going to write this down. 45 degrees plus alpha is equal to, well, I want to hit this one in the third quadrant, by the way. Right, the third quadrant. And what's that going to be? It's going to be 180 degrees right? And then I got to get that reference angle, add on to it. And what's that going to be? Arc sine of 1 over 3 root 2. Well, that's not so bad. And I guess I could write alpha down now. This is one of them. And 45 from 180 is 135. Plus the arc sine, 1 over 3 root 2. I want to do the one in the fourth quadrant now. And that's going to be 45 degrees plus alpha. That would be 360 degrees minus the arc sine, and this is the reference angle I'm taking away. Let's do the alpha now. You can get 315, taking 45 degrees from both sides. All right, what do they want me to do? I got to go back and read the question again. Look at the question. They want me to add up the roots, and there's only two. And the two roots are as follows. This one here, this one here. What's nice about that, when you add them together, those arc sines disappear. And what he left off with, I'll call this alpha 1, this alpha 2. Whoops, sorry about that. Let me go backwards. This is alpha 1, that's alpha 2. So alpha 1 plus alpha 2 is going to be 135 degrees. Again, the arc sines are disappearing, plus 315 degrees, which is going to give me 450 degrees. Make sure I did that right, by the way. 435 and 15. Yeah, it's 50. Now, again, I don't think it's a good idea to use degree measure. I'm going to convert this to radian, and that's going to be pi over 180 degrees. I'm going to reduce that now. That's 4, whoops, not 44. Let's erase that, right? And again, I'm just going to do it in stages over here. Degrees cancel. Dividing by 10, you get 45 over 18 pi. I'm going to divide by, let's see, 9 now, right? So 9 goes into 45 5 times, and 9 goes into 18 2 times. So the answer is going to be 5 pi over 2. And we're done. Thank you.